Hello guys, welcome back to another video. In this video we will consider an integral from 0 to pi over 2 tangent of t to the power of p dt. The first thing we should try to do is to get rid of this tangent. And how will we do that? We will introduce a substitution. T equals arctangent of y. Arctangent of y dt equals 1 plus 1 over 1 plus y squared dy. And since our integral is in terms of dy, we need the boundaries in terms of y. So we will solve this. Y equals tangent of t. We took the tangent of both sides to get this. Tangent of, when we put t equals 0, we get 0. Pi over 2 gives us infinity. And now, since we made it like that, arctangent and tangent, we cancel each other out. And now we have y to the power of p divided by 1 plus y squared dy. Now we will introduce a substitution. Y squared equals t, 2y dy equals dt, dy equals 1/2 y dt. I mean, t wasn't a good letter since we already used t. Let's use z, for example. I don't know. Let's use z. Yeah. Now it looks better. We need it in terms of y, since we have y here, so we can solve it. Y equals square root of z. And we already have y here, so this is also 1/2 square root of z dz. When we plug it all back in, the boundaries stay the same: 0, 0, infinity, infinity. The integral from 0 to infinity, square root of z is, and we will have z to the pi over 2, p over 2, minus 1/2 from here, over 1 plus z dz, and don't forget the 1/2 in the front. Alright, this is alright. Now we should know one form of beta function where the top is in the terms of alpha minus 1 equals to something, to the power, and the bottom part is in the form alpha plus beta equals to some number. This is to the power of 1, obviously. And now we need to solve for alpha. Alpha minus 1 equals what? P over 2 minus 1/2. Alpha equals 1/2 plus p over 2. Now we need to solve for beta, for the bottom part. Alpha plus beta equals 1. Pi over 2 plus 1/2 equals plus beta equals 1. Solving this for beta, we get 1/2 to the other side. We will have 1/2 minus p over 2. Alright, we need this and we need this. Okay, let's erase other things so we have some space. I won't derive the beta function and the things now because it will take too long, but maybe for another video. Now we will have 1/2 gamma of this, 1/2 plus p over 2 times gamma of 1/2 minus p over 2. Let's erase this. P over 2 divided by the sum of these two. 1/2 plus p over 2 plus 1/2 minus p over 2. P is between 0 and 1. I forgot to mention. And now p over 2 and p over 2 will cancel each other out. These two will be 1. Gamma of 1 is 1. So I can erase all of this. I hope you can follow. Now we will use the refraction formula, gamma of p. We will use this formula here, gamma of p times gamma of 1 minus p equals to pi over sine of p pi. In our case, this one is this one. I mean, this one is this one. So you'll just replace p with this expression. Let's do that. 1/2 pi over sine of what? 1/2 plus pi over 2, I mean p over 2 or whatever, times pi. This is all together in sine, not a different pi. Alright, so what happens now? We need to simplify this expression as much as we can. Let's do it here. Let's do it here. It will be sine of pi over 2 plus pi p over 2. Sine of pi over 2 cosine of p pi over 2 plus sine of this expression p pi over 2 cosine of pi over 2. What happens now is that this is 0 because cosine of pi over 2 is 0. So we will have just this one. And so our result is 1/2 pi divided by cosine. I mean, this is cosine because sine of pi over 2 is 1. So this is cosine of p pi over 2. Or if you want, you can write this as a secant, but it doesn't matter really. Alright guys, that was it for this video. Like, share, and subscribe if you want to see more of this. And see you in the next video. Bye guys.